these very persistent weather patterns are becoming more likely, sometimes interspersed with just the opposite. So a long drought and then a flooding period of rainfall. So it's going to become much more challenging, and there isn't always a good solution to figure out how to deal with something like that when it's so extreme in one direction and then extreme in the other direction.
In this ClimateGenn episode, I'm speaking with Professor Jennifer Francis from the Woodwell Climate Institute. Jennifer is a leading expert on the changes going on in the Arctic region, and as she says, these changes will impact everyone on Earth. The Arctic is a gigantic ecosystem worthy of our protection, and yet at this time world powers talk of domination and resource extraction, demonstrating hubris and reckless ambition, when what we need is a unified plan for restoration and preservation. In the next episodes, I'm speaking with Dr. Zita Sebesvari about the UN University's annual risk report. I also speak with Dr. Mike McCracken on solar geoengineering and Dr. Alexander MacDonald about how supergrids can revolutionize the global energy system for a resilient future. I'll also be uploading tomorrow for members and then releasing as part of a larger campaign on the 14th of May, a special 9-part video series with free ebook about how farmers in Alentejo in southern Portugal are using regenerative farming techniques as part of a wider sustainability program to build resilience against worsening climate heating. The project is called Into the Heat and covers a 2-week road trip last summer with my guests, climatologist Professor Jason Box and author-broadcaster Janet Wang. This was a fascinating project to produce in partnership with the Wines of Alentejo Sustainability Program. Thanks to all subscribers. Please do feedback, like and share. Jennifer, it's great to see you. Thank you very much for giving me the time. Recent reports show month-by-month record Arctic sea ice loss. Can you tell us how the characteristics of seasonal change have really sort of changed in the Arctic over the course of the last few decades?
Yes, we're continuing to see the sea ice disappear in the Arctic Ocean. We have different ways of measuring that. We can measure how much real estate it covers, which we call the extent. And we just set a new record for the lowest amount in the winter, which is when it reaches its maximum extent. So that is a very important milestone to set a new record like that. But also we're watching the thickness of the sea ice continue to decrease. And that tells us a lot about the overall health of the Arctic sea ice itself. The extent is affected more by winds, and so it's a much more fluctuating type metric, but the thickness is something that really integrates all the forces acting on it over a long time. And so seeing that continue to decline and losing the really thick ice, which a lot of marine mammals depend on, is very disturbing, but not unsurprised. Nobody's surprised by this trend because the Earth is warming. The Arctic is continuing to warm at 3 to 4 times faster than the globe as a whole. We're seeing the amounts of various greenhouse gases continue to increase in the atmosphere. So there's really no reason to think that this warming and melting is going to stop anytime soon.
And when you talk about the impact on ecosystems, how does that kind of information get fed back to you? How do you see it?
I am not a marine biologist, but I do follow other people's work that are studying this because the system is all connected. And what affects the physical part of the system, of which the sea ice is a part of that, and the ice sheets and the glaciers and the snow, that's all part of the physical part of the system. And seeing those things change so dramatically, we know it's going to also have an effect on the animals and plants and the people who live up there. So the ecosystem is intimately connected to the physical changes in the Arctic.
Okay, and as you see these different feedbacks and how they sort of interact with each other and others accelerate the warming, etc., can you talk a bit about some of those, of how they do interact with each other and what's happening?
You know, the sea ice feedback, or albedo feedback as we call it, is probably the simplest one to understand because basically ice, and also snow has to be included in that. So the snow that falls on the land. As we lose those bright white surfaces like the ice and the snow, then the stuff that's underneath, whether it's water or land, is much darker and it absorbs a lot more of the sun's energy. And so if you absorb a lot more of the sun's energy instead of reflecting it back into outer space, you're warming whatever that is, whether it's the ocean or the land. And so by warming that ocean or land, you're then melting more snow, you're melting more ice, and this sets up this vicious cycle that we call this albedo feedback. Albedo is just a fancy word for reflectivity. Another really important feedback, there's two more actually, that don't get as much attention, and that is as we lose the sea ice, we expose more open water, and there's more evaporation of water from the ocean into the air. And water vapor, that gaseous water, is a greenhouse gas, just like carbon dioxide and some of the other ones, methane, everybody's heard about. So by putting more water vapor into the air because of the loss of the sea ice, but also the warming of the air and the warming of the ocean and more evaporation, we're adding to the blanket, that greenhouse blanket over the Arctic. And so that also is setting up another one of these so-called positive feedbacks that makes that initial warming even worse. One more of these feedbacks involves permafrost. So permafrost are the frozen soils. They've been frozen for hundreds and sometimes thousands of years up in the high Arctic land areas in the tundra. And as this permafrost starts to thaw, it's like taking hamburger out of your freezer and leaving it on the counter. Let's say you go away for the weekend and you forgot that you left it on the counter, and this hamburger starts to decompose. When it does, it starts to release either carbon dioxide or methane, and both of which are greenhouse gases. So that adds to, again, this heat trapping blanket of gases in the atmosphere, which adds to the warming and continues the thaw of the permafrost and the melting of the other types of ice. So there are many of these positive feedbacks that involve frozen water up in the Arctic.
As we advance along this timeline, do these become more intense? How does it start to unfold? Do we go through the zero summer sea ice phase? Is that something you see coming towards us?
Well, in terms of sea ice, I think most of sea ice scientists think that we're going to see a summer with virtually no sea ice left, probably within the next 20 to 30 years. And that's not very long. But even when all that summer ice disappears, we're still going to continue to get this disproportionate Arctic warming happening, because that just means even more of the sun's energy will be absorbed by the ocean up there. And so it'll warm even more and make it harder for that ice to grow back. In terms of the permafrost, it's very thick in a lot of places. So that thawing of the permafrost can continue for many, many years. And I just wanted to go back to sea ice for a second. I meant to say something about the winter. So the winter season in the Arctic is going to continue to have plenty of sea ice, because it still gets dark up there for 6 months of the year, and it's still going to get extremely cold in the winter. So we will continue to have winter ice for a long time to come. But it's also getting much thinner, as we already talked about. And that thinner ice melts more easily when the sun rises in the spring. And it's also more easy to move around by the winds and the currents in the ocean. And so it makes it much more vulnerable to any fluctuations in either of those things. And so we're seeing an ice cover now that's just becoming much more vulnerable and much more susceptible to big fluctuations.
I've seen references to a wetter Arctic. Can you talk a little bit about that?
Well, of course, having more moisture in the air means that when a storm does form up there, it's going to have more moisture in the air to condense into clouds and to dump as either rain or snow. So this is partly why we're seeing the Arctic becoming wetter. And it's not just the Arctic that has more moisture in the air. It's the whole world. The whole globe has seen a 4 to 5% increase in the amount of water vapor in the atmosphere. So storms everywhere have more moisture to work with. And in fact, that water vapor is the source of energy for storms. And so if they have more water vapor, They also have more energy, and so they're becoming stronger. And we're seeing that that's true for storms in the Arctic, it's true for hurricanes, it's true for thunderstorms, and any kind of storm you can think of, because that is the source of energy. So water vapor is a really important part of this larger story because it has these three really big impacts. By having more water vapor, again, it's this greenhouse gas, so it's making the warming even greater. It's providing more moisture for storms to feed off of and dump as rain or snow. And it's also providing more energy for storms to use to become more intense.
I'm just thinking as well, it's obviously, you've mentioned ecosystems, but there are a lot of communities in the Arctic who must be absolutely devastated, trying to adapt and so on. And we're also seeing a lot now in the media about military activities and planned shipping routes. As someone who studies climate systems and how they are interacting with society, what worries you the most about our ideas and designs on the Arctic from countries that, are looking to extract or monetize it in some way?
Yeah, there's a lot to worry about up there. In terms of fisheries first, changes to the ecosystem and changes to the different animals that have always lived up there. We don't have a good baseline on what the ecosystem looks like in the high Arctic, where there used to be ice covering the ocean, because we really couldn't get a lot of information there. So it's hard to know what's changing, how it used to be, but we do know that there are species arriving up there that have never been seen before. There are species being displaced. The people who live up there used to catch certain kinds of fish, and now they don't see those anymore, but they see these other kinds that have come up from the south. And right now, I think there's a moratorium on fishing up in the Arctic. I don't know whether that's going to hold in the current situation, political situation around the world, but it seems like a very important thing. And as we mentioned, the people who live up there, this is just one of the ways in which their traditional lives are being upended. That plus the fact that they're used to having the sea ice for their transportation to get out to hunt animals and to fish and acquire their traditional foodstuffs, and they are not able to do that anymore in many cases because of the ice being too thin or just plain gone. And on land, their transportation is being disrupted as well because of the thawing permafrost. And during the winter is when they're able to get out on their ski mobiles, but their roads are buckling. It's just becoming much more difficult for a lot of these communities up there, never mind the erosion along the coastlines from storms creating bigger waves in larger ocean areas. So they're facing a lot of challenges up there. But then there's the commercial aspects. And, there's a huge increase in the number of ships that are using the Arctic to transport goods from Asia to elsewhere. And I think the big concern up there with that is that, the charts aren't that great. The ice is still moving around, even more so. If a ship gets into trouble up there and goes aground, ruptures in a fuel tank, for example, there's no facilities to assist with the oil spill and the people. And so there's just a lot of risks associated with this increase in commercial activity. And there's a lot of concerns about also extracting minerals and oil and gas from these newly open ocean areas and the potential pollution that might result from that, because we've certainly seen offshore oil and gas industries running into trouble even when there isn't any ice. And so this is a real risk to go into those areas that are much more vulnerable to big chunks of ice coming along and taking out a pipeline. It's also very expensive. So I think some energy companies are even reconsidering whether they even want to try.
Yeah, I suppose with a limited season that you can operate up there in daylight and stuff, it must be fraught with risk and danger. And you've done a lot of work on how the Arctic interacts with the jet stream because of their relation to our agricultural systems and things like that. What are the recent observations on that?
So a lot of groups are working on this exact topic these days. And I'd say the linkages or the connections between the Arctic and weather patterns in mid-latitudes are becoming stronger through this research. We know that it's a very complicated and noisy system, so it's very hard to determine any given extreme weather event, for example, or any particular year, how much the Arctic change has influenced those particular events. But it's becoming clearer and clearer that as we see the Arctic change so much, that it is having an influence on both winter and summer weather patterns through kind of different mechanisms. But it's still a fascinating and controversial area of research. But I think the evidence is piling up pretty substantially on the side of course, the Arctic is going to have an impact on our weather patterns because we're changing the way the temperature patterns exist in the Northern Hemisphere. And that is what drives winds. It's what it affects the jet stream, but it's just hard to know exactly how. And there's a lot of competing influences and changes in the Earth's climate system, in the tropics and ocean heat waves. And so all these things are happening at the same time in the real world. And so that's why computer models and climate model simulations are really important in helping us understand how some of these changes are interacting with the Arctic change.
I see China outlined a 10-year agricultural plan from food security, and Japan is opening up its rice stockpile. In the UK, there's a lot of scientists warning on food security, and it seems like such a critical aspect of all of our lives. Aside from being able to build these links, are there things that come out of it in terms of what we could do to become more resilient, aside from stop the problem getting worse by burning fossil fuels?
Yeah, well, that's the underlying disease, and that's what we really do have to focus on and treat in the long term, but we have to do it quickly. But otherwise, the other solutions are really all about adapting to the changes that we expect to happen and the extremes that we know are going to get worse. So there's a lot of things that people are trying. It's hard to deal with very long-lived droughts that we know are going to increase in many areas. Farmers are experimenting with different types of crops to plant. They're trying to figure out ways to store water so they can, water their crops. But I think just the realization that these very persistent weather patterns are becoming more likely, sometimes interspersed with just the opposite. So a long drought and then a flooding period of rainfall. So it's going to become much more challenging, and there isn't always a good solution to figure out how to deal with something like that when it's so extreme in one direction and then extreme in the other direction.
You alluded to the politics being difficult at the moment, and no one really knows how that's going to play out. But when you look at the state of the Arctic and the importance it really has as part of the global climate system, what's your sort of best case that we could hope for? I don't know if saving it's the right word, but is there a good outcome to this that you can see in any way?
So I think, just on the political side of things, the fact that the Arctic states, so the Arctic countries, exclude Russia now in terms of cooperative research. I mean, they're a huge part of the Arctic, and yet we're really not able to work together anymore. And that is a huge detriment to moving forward with understanding how the Arctic's changing, what we can do about it. So that is a real, I think, catastrophe, really, in terms of the political situation. And in terms of whether there's a good outcome, I think there's a bad outcome and there's a better outcome. I'm not sure that there's a good outcome. Better would be doing everything we can do to slow down the change. I don't think there's any way we can stop the change. So that's true, not just in the Arctic, but globally. We have to do everything we can do to make it less bad for our kids and their kids, but we really can't stop a lot of the change that's coming our way. So that's what I think we need to focus on.
And in the past, scientists have been able to collaborate above and beyond the political situation. Do you think that that could be achievable now if there was pressure towards it?
Well, it's achievable for sure, because scientists speak about science, and usually, as you say, politics are not part of that. But if it's not allowed, if we can't get together and we can't have conferences where everybody gets together and talks about their work and shares their insights, that's how we make progress. So it's definitely a big deterrent, and it's going to definitely slow things down. in terms of making progress. So yeah, it could definitely be improved quite easily, I think. It would have to come from the Russians. I mean, they're the ones who have alienated the world by attacking Ukraine. It's as simple as that. So now we just cannot interact with them anymore.
Quite a comprehensive update on various aspects of climate change in the Arctic.
If we want to leave on a more positive note, I think we could find one. People are learning about the Arctic. I mean, it used to be this faraway place that nobody really cared about at all. And I think the messages are starting to get through that what's happening there is affecting all of us, whether it's sea level rise or weather patterns or the fish we eat, or, I mean, you name it. It's got an influence on just about everyone on the planet. And so I think that is a great communication achievement, that we're starting to educate the public about really the interconnectedness of the climate system, and one country cannot solve the problem. It's going to take all of us, but yet we are still in for some more big changes that we're going to have to work to minimize their impact, especially on people who had the least to do with causing them.
So increased awareness of the region could be a way of influencing what goes on in the region by just caring more about it.
Yeah.
Thank you very much.
Okay, anytime.
If you are concerned about the future, then why not travel with me through every COP conference from COP21 in Paris to COP28 in Dubai by ordering my book COP Out: How Governments Have Failed the People on Climate. In COP Out, you'll gain insights into what is actually going on in these supposed world-saving conferences, and how we have ended up in this dire era of dangerous consequences. You can order COP Out via the link in the notes or on any online bookstore worldwide in paperback or audio version.